Hello, everyone. Good afternoon from London, and welcome to the first in a series of autumn webinars about the new climate adaptation and risk assessment tools that are hosted on Oasis Hub and how they might be able to help you. So with more frequent flooding, storms and extreme weather, your role, whether it be in insurance, municipalities or elsewhere, involves taking informed decisions about climate risk assessment, adaptation and resilience strategies. And this includes analysis of current and future hazard and risk, climate change impacts, and also the quantification of the damage and financial losses of a flood in a specific place. So we at Oasis Hub understand that for many professionals, being clear about which flood tool to use linked to your specific objectives isn't an easy decision to make. So we decided that the first 3 webinars this autumn will aim to help you understand the types of tools that you could consider. We're going to hopefully demonstrate how, by talking to scientists and flood specialists themselves about the state-of-the-art specialist flood tools that are available, showing the diversity of tools that are available to you and helping you decide what types of tools work better for the challenges that you need to address. So the 3 webinars in September and October are going to cover flood risk and predictive models, flood forecasting, damage and loss assessment, and climate change adaptation for urban areas as well. So the first webinar will be presenting a really exciting, unique new tool to help you with damage assessment and the potential for adaptation planning. It's called the SaferPlaces platform, and it can help assess flood hazards and risk, including pluvial, fluvial and coastal flooding in urban environments under current and future climates. So the tool has been designed with the possibility of testing climate adaptation measures against potential floods, and importantly, also allows for the calculation of potential financial damages. So what I'm going to do now is hand over to Stefano Bagli, who is an environmental engineer, data scientist, CEO and founder of Gecosistema. And he has more than 20 years experience in environmental modeling and data science in the field of climate services, hydrology, flood hazard and risk mapping. So he's going to tell you everything about SaferPlaces, which is the climate service mapping flood hazard and risk assessment in urban areas as a means to build safer and more resilient communities. So hi Stefano, welcome. How are you getting on today?
Hi, thanks a lot, William, and thanks a lot to all the Oasis Hub team for setting up this great opportunity for us. Many thanks also to all the participants that are here with us this afternoon.
No problem. So, I just wanted to add, if anybody has any questions throughout the presentation, Stefano will give his presentation, and if you've got a question, just put them in the chat box, and we'll have time for questions at the end. So thanks, Stefano, over to you.
Okay, thanks. I will try to share my screen. I will stop the video just to save connection. Okay, sure. Okay, so today we'll present the brand new SaferPlaces platform. It's a cloud web climate service for mapping hazard and risk in urban areas. Before presenting a live demo of the platform, I'll give you an overview of the SaferPlaces project, the intelligence behind and the purpose of the platform. SaferPlaces project has been founded by EIT Climate-KIC, and the project started in July 2018 and will last the next year. The project is coordinated by my company, Gecosistema, and is implemented together with the following partners. We have 2 research centers from Germany, ZFZ, and Italy, CMCC, 2 universities, Bologna and Politecnica di Madrid, and 2 other SME, Mio company in Italy and Hummer Consultancy from Austria. We have also on board a panel of potential end user and stakeholder, including insurance company, local administration and cities, multi-utility company, and emergency authority. All of them has been engaged in a co-design and co-development process in order to have a better design of the platform. So the issues related to SaferPlaces project is to try to answer this question: what are we doing to save our city from actual and future flooding events? So nowadays, our cities are flooding with the increased occurrence, in particular due to more severe weather events, but also due to anthropogenetic pressure like soil sealing and subsidence. SaferPlaces platform aims to address flood hazard and damage assessment in cities, in particular related to 3 sources of flooding. The first one is pluvial, and then fluvial and coastal. The SaferPlaces challenge is not only to predict and assess urban flooding, but also to present consequences and support action towards it. And with the use of the platform, we want to contribute in increasing awareness and capacity building for support flood climate resilience among different stakeholders. So we need new tools and services to guide action at multiple levels in multiple sectors. The cost of inaction related to flood in cities are very high. For example, here are reported 2 recent papers focused on damage cost assessment in city due to coastal and pluvial flooding. Damages and losses are not negligible. For example, a pluvial medium intensity rainfall event of 60 mm per hour can generate more than 10 million of euro of economical losses in a city like Rotterdam. And the cost of flooding related to coastal is even higher, with billions of losses on natural scale. So action means redesigning our cities in order to be more resilient to our floods. And besides simplistic or utopic approaches, urban city master plan have both the possibility and the chance, but also the burden to solve this problem. And the platform, SaferPlaces platform, and the tool that we have developed can give the planner the ability to test effectiveness of multiple vision of the city development, to test multiple mitigation measures or development scenario, for example, the integration of green and blue infrastructures, and also involving the community in a mutual agreement to our resilience based on shared comprehensible understanding of the ongoing phenomenon and proposed solution. So in this context, the flood hazard and damage tool play a big role. And the current standard approach is based on the use of a complex hydrodynamic numerical model that require high cost and CPU processing time, are usually data intensive, and require also the hiring of a specialized consultant. So for those reasons, only few people and the organization can have enough resources and time to proceed in complex numerical simulation. And the current approach also suffers from several limitations. First of all, the available flood hazard and damage maps are static. They are only valid for historical or actual condition, both for climate and urban settings, and are not representative of a changing climate and, for example, evolving city, as you can see here in the slide. And moreover, the available maps in most of the city are not spatially explicit. In general, are available at low resolution, and for example, parameters like water depth or damages are represented in a few discrete classes. Here, for example, on the left, we have the maps provided by Regione Emilia-Romagna here in Italy. As you can notice, the maps represent the flood hazard in 3 discrete classes and not in absolute value. On the right, we have the same maps generated with the SaferPlaces platform. Is a higher resolution and represent the spatial distribution of both flood hazard and also damages. Another limitation of available flood hazard maps is related to the fact that the maps sometimes are out of date. Here I reported the situation in US. The FEMA flood hazard maps are, for example, out of date for the 75% of the entire country, represented in gray. And in red, the 11% are flood hazard maps produced during the 80s. So maps need to be updated quite frequent. The last limitation that we have noticed is that urban areas and users need the possibility to quickly and cost-effectively test multiple scenarios, combining both climate condition and also future urban project and master plan. These procedures could be very time and cost expensive with numerical models, so we need new tools, faster and cheap. And we need also tools that could be extended to a wider audience, so a sort of democratization of flood hazard modeling and damage tools. So for this reason, SaferPlaces aims to overcome the mentioned limitation and address flood climate impact in our cities by supporting decision-making with the development of a brand new cloud web mapping service characterized by the following main point. First of all, we have developed and embedded in a cloud platform innovative and resource-effective pluvial, fluvial, and coastal flood hazard and risk mapping tools that are specifically tailored for urban area. Then we want also to exploit the increased availability of open data, in particular the geospatial and climate data made available by Copernicus initiative and platform. And finally, we want to co-design and co-develop the platform in time connection with the end users. In particular, we have 4 pilot cities, but we have also on board insurance company and, for example, multi-utility companies. So the SaferPlaces platform has been co-designed with these potential end users. So I've already mentioned the potentiality of the platform for cities, for urban planners, so the possibility to test multiple scenarios in terms of mitigation, in terms of adaptation, implementation of a green-based, nature-based solution. We are also working with the multi-utility company, especially in Milan. For example, they are interested in exploiting the platform for a better design and also management of the sewage system in order to face extreme pluvial events that are quite frequent now during the summer here in Europe, in Italy. We are working with the insurance and reinsurance companies that are interested in high resolution flood damage maps, able to define the potential losses building by building. So this will support them in a better risk profiling in order to reduce the underestimation of risk and the consequent increasing gap between earned premium and total losses. On the right, you can see a graph reporting the gap in US related to the earned premium and the real total losses in the last few years. Another potential end users of SaferPlaces platform is the real estate sector. In particular, with our high resolution maps, we can support flood risk disclosure, and we can develop a sort of flood score or index building by building in cities. And finally, civil protection and first emergency organization. We can support them in design specific urban first response plan. So the intelligence behind the platform, just I have a few slides about that. The first model is a Safer Rain, is a dedicated pluvial flooding model for mapping flood hazards in cities due to extreme rainfall. We have developed this innovative, effective way. This research has been published recently on a scientific peer-reviewed journal, the Water Journal. We got also the cover in June 2020. So Safer Rain is a dam-based model, in particular exploit the LiDAR, the high resolution digital elevation model that are available in urban areas, and require few input data. It can generate flood hazard maps in real time for several rainfall events, considering also the natural infiltration. If you are curious and want more information, I invite you to download the publication and read the details about the Safer Rain model. This is, for example, an application in the city of Rimini, located in Italy. We have simulated a rainfall intensity of 19 millimeters per hour with a duration of 1 hour. And we have computed the flood hazard, also taking into consideration the natural infiltration with the green-amped approach. And the output are quite consistent also with the reality. This is the model reproduces well the past event, for example, here in the underpass of Tripoli Street. Then we have developed Safer Coast, a fast region growing algorithm dedicated to map coastal flooding for a specific extreme sea level. It's written in Python, exploiting the NumPy library. And for the fluvial, the classical fluvial flooding, we have developed Safer River. Safer River is an artificial intelligence-based binary classification algorithm of the GFI, the Geomorphic Flood Index. Again, if you want some details about the procedures related to Safer River and how to compute GFI and how to classify the flood hazard maps, I invite you to read our latest public publication available online. And the Safer River algorithm compute through an iterative approach the best thresholds that maximize a Uden function in order to reproduce the best possible representation of a benchmark flood maps, here represented in red. So the algorithm is very fast and in few seconds can provide, for example, here in Cologne, can provide flood hazard maps for large flood prone areas. Another component of the intelligence behind the platform is the Safer Damage algorithm. Safer Damage has been developed together with GFZ, the research center based in Germany. It's a particular type of Bayesian networks damage model, and is an advancement that respects the classical depth damage function because it's possible to include multiple variables to estimate the losses, not only the water depth, but also other, for example, building characteristics. The model has been validated comparing observed and model data. And exposure both for commercial and residential are based on a new method that has been recently published of estimating useful floor space of individual buildings from available open data, in particular from OpenStreetMaps. Finally, the last element that composes the platform is related to the mitigation measures. The platform is able to assess the mitigation effect in terms of flood hazard and reduction in damages and financial losses related to several type of mitigation. We have structural mitigation measures that could be tested in the platform, for example, barriers like artificial dunes, leaves, or walls, but also the implementation of sustainable drainage system, for example, infiltration ponds, green area, green roofs, and permeable paving. And we have also a specific set of dedicated mitigation measures for buildings. So, for example, flood barrier for buildings or building dry and wet proofing and other kind of damage protection specific for buildings. So this is the framework of the platform. All the components that I mentioned and described before are embedded in a cloud computing framework. In particular, we have exploited the high power computing of Amazon cloud infrastructures. And so all the open data collected from several sources, exploiting, for example, API, are uploaded in the geospatial database inside the cloud infrastructures. And the main core element of the service is represented by the hazard and damage assessment model embedded in the platform. Finally, we have It's a web application, so we have a web server that provides the graphical user interface and permits the interaction with the end users, and the display of the results. So actually, we have the platform is available online and operative for 4 cities: Cologne in Germany, Milan in Italy, Pamplona in Spain, and Rimini again in Italy. The platform is accessible with a common web browser. I'll give you the details how to access to the platform later on, and doesn't require the installation of a specific software. So before starting the demo, the live demo, I would like just to describe the exercise, something about the exercise I will show you later. So we will work on the RIMINI pilot case studies. In particular, the idea is to test the use of the platform in assessing the mitigation effect related to a new sea promenade urban regeneration plan that is currently developed in Rimini. Rimini is a small town located in the east coast of Italy. It's a well-known beach destination here in Italy. And the local administration is developing a new sea promenade. And this new sea promenade will interest all the south part of the coastline. And the main project consists in designing and building a new seafront characterized by the increase of ground level of 1 meter, reaching the elevation of 2.85 meters above the mean sea level. So this wall, these artificial dunes, that is called Parco del Mare project, has a length of 7 kilometers and will cover and protect the entire south side of the Rimini seafront. The project also consists and is characterized by the presence of new green areas, dedicated cycle path and park that replace the old paved roads used for road traffic. So the renaturalization will increase the infiltration capacity of the area and reduce consequently the pluvial flood risk of the area during the heavy summer storm. So we have computed through the platform, we have built up a sort of economic damage model. And for example, we have computed the expected avoided annual damage related to the implementation of the dunes of the new sea promenade. The new sea promenade is able to protect the city of Rimini from coastal event, both in the historical scenario, but also in climate projection. We have evaluated the projection of 2050 and 2100. You can see on the right the percentage in terms of reduction of economical losses. So all this computation has been done through the platform. So I will switch to the live demo, and I hope, finger crossed, because this is a real live demo, I hope to not get any blue screen. So the platform is accessible through a specific web link I will provide you. The user can select one of the cities. So let's start with the Rimini case studies. At the first login, you need to insert your credential. You can, if you are interested, create an account and ask, inserting an email and name, and ask for a specific grant. And then you will receive some email. Now I'll log in myself. Okay. So now I have the credential. As you can see, the platform is composed by, on the right, a classical mapping environment. The user on the top has the possibility to zoom in, zoom out. He has the classic button that are quite common in all the mapping environment. And on the left, we have a list of pane where we can play and generate the simulation. First of all, the user can select and switch from different case studies. For example, here we pass to the Cologne case studies. So you can switch to different multiple cities or area of interest. And in the first task pane, we have, this is the most important, this gives the possibility to the end user to generate the 3 flood hazard scenarios, so pluvial, fluvial, and coastal. For example, we can generate a pluvial scenario with a return time of 100 here. We can define the duration here of the rainfall event. Automatically, the system upload the intensity that has been all the data related to the intensity and the climate condition has been already uploaded in the database. And it can also change the name, or it can even change manually the intensity of the rainfall. So this is for the rainfall scenario. For the river, we can map, for example, the return time 100 here. And for the coastal, we can select, for example, a future scenario with the RCP 4.5 projected here to 1100. So for example, we can simulate the extreme sea level with a return time of 100 here that correspond at 2.77 meters. Once we have defined the flood hazard scenario, we can add to the platform, and we can simply run the simulation. So now the Amazon Cloud Computing start the simulation of the 3 hazard scenario, but also start to compute the damage assessment. So it will take more or less than 1 minute, and in the layer panel we have the possibility to see and check the results that and the output that are continuously generated by the platform. So we are waiting now. We have river and coastal already generated. We are waiting for rain scenario, but also for the damages. In the layer, we can select and visualize this is the LiDAR behind all the hydrological computation, and then we have also the possibility to see the buildings and the land use. I will show you how to work with land use and buildings later in the implementation of mitigation measures. And we have also possibility to change the background of the platform using satellite, different satellite sources. Okay, so more or less we are waiting only for the damages for the rain. Let's have a look about the coast. So this is the coastal scenario of 2.77 meters. We are able to zoom. So all the results has been produced at 2 meters of resolution, and then the end user can identify and query which is the water depth pixel by pixel. And we have, let's switch off the rain. Okay, and we have also the possibility to identify which is the economical damage as associated building by building. So here are reported the value in euro. So this is the scenario for in actual condition related to coastal flooding. And then this is for the rainfall scenario. We have the same maps produced in real time in few minutes, exploiting the high power computing of Amazon. And again, we are able to map which is the flood hazard related to these pluvial events. And the same for the river, exploiting the GFI approach, the safer river model. We are able to compute quickly which is the flood hazard and the damages associated with a specific return time. So as already anticipated, the platform is also able to play with some mitigation measures. So we have some mitigation related to hazard models. For example, the user can define a specific physical barrier, and with this tool can draw a specific barrier, for example, like the similar that has been developed in the Parco del Mare, and can modify or can define also the elevation of the artificial dune. And then, yeah, maybe again I can insert 84. And so we are able to insert the multiple and different physical and structural barriers like artificial dunes, but also we can insert some water retention tanks that have a specific mitigation effect on pluvial events. We are able also to change the infiltration parameters and changing the land use in terms of specific mitigation measures. For example, we can define area where we want to extend the use of green roof, or we want to increase the infiltration capacity of the soil, so reduce the soil sealing in some specific area with the green areas or permeable pavement. We can develop in the city and test which is the effect of urban wetland or even storage tanks. So this kind of hazard mitigation can be inserted in the platform, and we have also specific mitigation measures related to buildings, so are a sort of a bit mitigation related to damages for buildings. So we can select building by building and associate for every building a specific damage mitigation. So in this case, we have building dry proofing, building wet proofing. All these mitigation will have an effect in terms of reduction of economical damages for a specific water depth. So for example, here, let's try to run an already developed mitigation scenario that is associated with the Parco del Mare. So in this case, we will simulate the presence of the artificial dunes and also the presence of green areas along the sea promenade. And so we can add another scenario. We can test the same condition projected to at 2,100, and we can run the Parco del Mare scenario. So let's see in terms of flood hazard and in terms of damages, which is the difference. So as you remember, here in the coast, we have already computed the water depth associated to the okay, you can see the difference between this is the condition of without the implementation of Parco del Mare, and this is the scenario with the implementation of Parco del Mare. As you can see, the dunes, the artificial dunes that we have created and inserted into the platform has a big effect in terms of reducing the extension of flood hazards, and it is reflected also in damages. So we have the south area of the city that is completely now safe for this coastal flooding scenario, and this is the situation of today without the implementation of this scenario. So the platform is completely operative. We are now working in inserting more function. For example, the implementation of expected and annual damages will be ready soon, and also a dashboard that will display all the results, also make a sort of comparison among the different scenario. So in terms of deployment of the SaferPlaces platform, so the platform is available and ready to be embedded and implemented worldwide. Usually we operate in 3 phases. So we need a sort of setup phase where we embed into the platform all the data set that are requested. And usually we work with LiDAR, land use, and litology for the urban area of interest. Then we will proceed in a sort of validation phase. And we start also a comparison, a benchmarking with the available flood hazard and damage data in order to calibrate our tool. And finally, we have the operational phase with an annual subscription. So the user just buy an annual subscription and will be able to use the platform independently for whatever scenario you want to simulate. The roadmap of the development in the next year will be to combine also multiple flood scenarios, so to give the possibility to simulate, for example, combined pluvial and fluvial, pluvial and coastal, something combining multiple sources of scenario together. And we will develop the dashboard, and also we are working with a API development, and also we are trying an integration with the Oasis Hub and the Copernicus data. SaferPlaces platform is ready to is scalable, is ready to grow and to sustain the heavy traffic in terms of multiple users. So if you are interested, I will invite you to test the platform. You are able to play with the 4 cities. The platform is available online at the following address, platform.saferplaces.co. If you go in the website of the project, saferplaces.co, you can have also, you can access to the sort of a tutorial, recorded video tutorial. And in case you need some assistance, so please contact me or contact us through our communication channel, the website, the Twitter account. So thank you for the attention. I'm here happy to answer to some questions and doubts in case you have. Thanks a lot.
Thanks very much, Stefano. It's an extremely exciting new tool, and something I hope everyone attending can use to build safer and more resilient communities. We have a couple of questions. We'll spend the next 10 minutes or so, if we have any other questions, just running through them. So if you do have a question, just type it into the question and answer box at the bottom of the screen. So I think the first question from Humi, you touched upon this already. Hi, Stefano, can you run a model for any part of the world, or is the model only covering the pilot countries that you've shown? So I think you touched upon that, but I don't know whether you wanted to add anything.
Yeah, basically we need a sort of setup phase in order to upload the few input data that we need. For example, the digital elevation model, the LiDAR or the land use. Most of the data are already available and covering most of the country in the world. So for example, in Europe, we are completely, we can cover 100% of the entire Europe. Maybe in some other country, we should check the feasibility, but yes, the answer is yes, we are ready to be operational, to provide the service for every city in the world. And if you are interested, just ask to us. We will give an update.
Cool. We have another question from Paul Hudson. It goes, for the building level mitigation measures, do you have examples of what measures are included in the package? For example, is dry flood proofing assumed to be a single measure, like a 1 meter high flood wall, or a bundle of different measures?
Yes, actually, we have embedded some simplified mitigation measures for building. For example, the dry flood proofing is, yes, it's considered like a wall, a barrier, a physical barrier that protects the building. And the user in the platform can also define which is the height of the building. So we are able to reduce the water depth or to not consider the building flooded because has in place the wall. But we are also extending to other measures. So up to now, we have 7 specific measures focusing on building, but we will update soon with other measures. It's quite flexible, the tool, so, and the model, the safer damage model. So we have a high potential to cover different measures.
Excellent. We have a third question from John Maskell. He says it's a great looking tool. Congratulations. Can the platform look at the impact from joint events, for example, fluvial and coastal, or fluvial and pluvial? Is there a way to look at the impact of clustering, for example, two consecutive rain events where the second rain event falls on saturated ground?
Yeah, thanks for this question. It's a very interesting question. Yes, we are working in combining, as I already mentioned at the end of the presentation, we are working combining multiple flood events of different sources, so fluvial and coastals. This is completely possible. We are also working in the pluvial. We are working with the possibility to take into account the saturation of the ground. So the infiltration capacity is different if the saturation of the ground is 0 or is completely saturated. We can even work with satellite data in order to detect and assess which is the level of saturation of the ground at in real time. So this is something that is possible. Yeah. And there is another question. Yeah, the possibility to clustering the impact. Yes, there is a way to do that.
We have another question in the chat. Thanks very much. From Demosthenes. They ask, is it possible to run climate change scenarios other than RCP 4.5?
Yes, yes. So in the demo that in the live demo that I present today, for the RIMINI pilot, we have only implemented the data available for RCP 4.5, but yeah, this is something that it could be extended to RCP 8.5 to whatever climate change scenario. So here in the live demo of the RIMINI pilot, they were interested to this specific scenario, so that's why I used only those climate projection.
I have a question myself. Who would you say the main beneficiaries are of the SaferPlaces service?
Yes, again, the platform is designed has been co-designed and co-developed together with multiple stakeholders, so it's cross-sectoral. We have worked a lot with the urban planners in several cities. But we are also working together with the insurance and reinsurance companies. So, for example, they are very interested to get high resolution data in cities in order to support the risk profiling with a high resolution data set related to hazard and also damages. There is a strong interest also in the multi-utility company that want to assess which is the flood risk related to pluvial and the role of the sewage system. So they are interested to design and also better manage the sewage system during a big storm. So yeah, the platform is flexible and could be also even adapted and tailored with specific function in order to cover specific needs from different and multiple stakeholders and customer and users.
Brilliant. So I'll give our participants one more opportunity to ask any question they might have. I think we've covered the process for adding a new city to the platform. We've talked about who the main beneficiaries of the service are going to be. And I'm being told there is another. Okay, so we have another question that has just come in now from Pumi again, who asks, are there any damage functions used in your damage estimation module? Can a user upload their own? And are they object specific or generalized?
Yes, SaferPlaces now a platform as embeds the GFZ Bayesian damage model. So it's a more advanced model in terms of damage computation, respect the standard damage function. So there is not now the possibility to insert a dedicated or a specific or a tailored damage function by the user. So we have this more advanced Bayesian model. But yeah, in case you want to add this function, it's quite straightforward to add. So the platform can be flexible and ingest and process specific users' damage function.
I'll give people maybe one more minute to ask any questions, but I'm pretty sure we have covered most of the questions that I had about the platform in your presentation. So unless anyone else has any other questions, doesn't look like it. Just to say thank you very much. Again, it's an extremely exciting new tool. If anyone has any questions about this tool or any other tool that you can find on Oasis Hub, please do email us. We're on hello@oasishub.co, and we'll be back in touch with you. Oasis Hub is, of course, the global window to free and commercial environmental and catastrophe risk data tools and services. The next webinar is in a fortnight on the 5th of October. Ambiental Risk Analytics will present 3 of their tools which aim to support better decision making around flood risk management. I understand at the very last moment we've had one more question. So Florian asks thanks you for the presentation, and asks, how are you evaluating the values of the different assets modeled?
Actually, we are exploiting this new approach developed by GFZ in order to evaluate the value of assets, both for commercial and residential buildings. And yes, it's based on the open data made available by OpenStreetMap. And if you want more details, I strongly invite you to read and to have a look about the paper. I will show here the paper reported in this slide. Anyway, you will have the recording of this video,
and we can
tutorial. So natural hazards you can see in the bottom of the slide. You have all the details about how to evaluate the value of different assets embedded in the platform.
And again, if you want to get in touch about the tool, Florian, directly, you can reach us hello@oasishub.co. And I've posted some links in the chat box as well for people to follow, just so that you can navigate to the SaferPlaces platform and also to our upcoming flood webinars. So once again, Stefano, thanks very much for your time showing us this amazing new tool. I hope it's extremely helpful for everyone who's participated today. And please do join us again in a fortnight for our next flood webinar. Thank you very much.
Thank you, William. Thank you, Oasis, and all the participants. Have a good afternoon.
You too.